Welcome to section 2, Categorization of Design Patterns. In last section, we got to know what design patterns are, its benefits, design principle behind it, and related information. In this section, we are going to learn no silver bullet to solve all design issues in software, recognize the pattern of problem and design solution around it, categorizing design patterns, framework architecture. No silver bullet to solve all design issues in software. In this video, we are going to take a look at what is cyclomatic complexity, what is tight coupling, what is loose coupling, is there a design pattern which can solve all issues. What is cyclomatic complexity? Cyclomatic complexity is a source code complexity measurement that is being correlated to the number of coding errors. It is calculated by developing a control flow graph of the code that measures the number of linearly independent paths through a program module. Here is its formula. If we look at the graphical view, it would look something like this. So to understand it better, let's quickly jump to a code example. So in this example, we have been given the 4 numbers and we need to print whichever is the biggest number. In first video, we learned how to write better code. Now here is the example which is kind of opposite of that. So what has been done over here is A has been compared by several other numbers B, C and D, and if it passes all these nested if conditions, then it prints it. Similar thing has been repeated, so it's a wet code wherein we are writing every time this condition. However, this code works fine. So the code which works might not always be the best code, but it works. So let's understand the problem. So first thing is there are too many decision points, it's not linear, and then it's like a spaghetti code because it rotates, it has too much nesting inside it. And the biggest problem is tomorrow if requirement says that we need to add another number in the comparison, let's say E is equal to 100, then there will be a lot of impact on the code. Design pattern gives us some solution or guidelines which would help us to do the same thing with minimal code changes. So let's first try to understand the problem. So here we might need to add another condition which would say if which would say if A is greater than E, then we might need to print A. Now the impact is not only on this, but since we have the wet code, it is getting repeated. So we have to compare each and everything something like this with the E. So there is a lot of places where the code needs to be changed and it's really complex. Not only this, like we need to also add another condition, something like this, wherein we'll be comparing the E since we have comparison with A, B, C and D. So we might need to add another condition wherein we have to compare E with every number. So this code looks complex. That's what when we were looking at the figure, the graph says you should have linear code. You shouldn't have too many decision points. Just to figure out the bigger number, you don't have to compare at too many places or to have too many decision points. There is a saying, it is very simple to be difficult, but it is very difficult to be simple. Now we'll look at the simplified version of the code. We are kind of inspired by the delegate design pattern, and how it works is we need to pin the biggest number. So let's try and run this. So of course this gives us the biggest number, but we apply the KISS principle here. Don't go in your imagination. Case here is keep it simple, silly. So we are just having a small code. Here the code works, but code is so long, like about 60-80 line, and with time it will grow more. So we have acted a bit smart over here. Whatever are the numbers, we have delegated it to the external components or libraries, and we get the result. Let's try to add another number as part of change requirement. So we have E with the value 100. Now what we need to do is we just need to change a parameter, and that's it. Once we add an argument, it's highly dynamic code. It's designed in such a way that it can absorb changes really easy, and we get our number. So that's how we can be simple, even though being simple might be a bit difficult, and being difficult is super simple. So now if we'll try to relate our diagram, it looks so complex because there are so many decision points in loops. We just try to make it as straight, as linear as possible to reduce the complexity of our code. What is tight coupling? Tight coupling is when a group of classes are highly dependent on one another. The scenario arises when a class is not designed to be independent and assumes too many responsibilities, or when one concern is spread over many classes rather than having its own class. The tight coupling between classes creates a ripple effect, which means when one class is changed, it impacts too many other classes. A minor change in one class would need to modify and compile many other classes. What is loose coupling? Loose coupling is achieved by means of design that promotes single responsibility and separation of concern. If the only knowledge that class A has about class B is what B has exposed through its interface, then A and B are said to be loosely coupled. A loosely coupled class can be consumed and tested independently of other concrete classes. So here is a clear distinction between them. Tightly coupled classes are more interdependent, which means any change in any class will have a ripple effect all over. However, loosely coupled can be developed, can be modified independently. Let's see this with the example. So in this example, we have a client file and a traveler. So traveler can travel with car, bike, or truck. That's how it is. So in the client file, we are holding the object for different vehicles. Now let's try to run this. So everything has a method called as move. So let's try and go to check the implementation. So here is how car looks like. It has a method move. Similarly, if we go to bike, it also has the same. But the problem is they are tightly coupled, which means even if you make change in one class, any minor change will start breaking the client. So here you see that we have started getting the problem. Now, whenever there are any classes which would be added, there will be a lot of impact in the entire system. The client will break. So we will look at how we can do loose coupling so that the end client or the consumer might not have the major impact, or it doesn't have to go through entire retesting. So here is the client for loosely coupled class. The client does not need to know the implementer. We are following the design principle of programming against the interface, which means all the vehicles which have common method which are move, they are being abstracted in an interface called as vehicle. Now when we get the object reference of this, we just go here and then the getter This is something like factory we'll learn in the deep as we go ahead in the course. So we get the object against the interface, and then the polymorphism is in full force. So if we try to make change in the bike, let's try and rename this guy. So we just renamed it. So the problem is only here. If we go to the client even doesn't know there, or it's not been exposed, or it's not impacted. So the design says that if things are loosely coupled, they can be generated in an independent way. Now here, it is very easy to add any subclasses. Tomorrow, if we say we have a vehicle with a plane, we just add a method in the factory and then we'll get that. And by the virtue of polymorphism, it would be super easy to go ahead and consume it because they are loosely coupled. So the takeaway is class needs not to be modified or changed, compiled or retested when any subclass needs to be added or changed. All classes are independent. So that's a takeaway for the loose couple and the tight couple. Interfaces are powerful tool to use for decoupling. Classes can communicate through interface rather than other concrete classes. As we have seen here, that the programming was done against the concrete class, not against the interface. Is there a design pattern which can solve all issues? So what we have saw that there are loose coupling issues, tight coupling issues, then there could be some complexity issues. So is there a single design pattern or just a bullet or a master key which can be applied and then it solves all the problem? And the answer is no, because as we know there are different keys for different locks. So in our software, whenever there are problem, we need to do the solution around it based on the problem. Summary. We saw what is cyclomatic complexity, what is tight coupling and loose coupling, and we realized that based on the problem, there are different solutions. There is no single bullet or a single design pattern which can solve all design issues. There are different design patterns which are focused to solve different design issues.